My name's Adam Greenberg. Thank you again for coming to our talk. Kurt won't be able to make it today. He was dealing with insomnia last night, and so he will be missing this presentation. So apologies in advance if I am staring at my laptop trying to cover some of the slides that he was supposed to do. Anyway, why we're here today? So we're here to discuss a project that we both spent a couple of months on last year, and what we did to get this project that was scoped out for 4 months to be delivered in 40 days. Today we'll be covering the teams and the tooling we use, stats, metrics, and objectives, 400 fragments, and in those 40 days what happened, and then a quick wrap-up. So we're not 10x engineers. This talk is not about how to be a 10x engineer, but hopefully how to look like one in hindsight when things go wrong and sideways. So this section will cover who we are, what we're working on, and more importantly, for me at least, who are the people that make us look good? So, I forgot to mention in our intro that we're both engineers at Pinterest, working on the Android app, and the Pinterest app is 14 years old. It's old enough to go to high school, and as such, the Android app's built and maintained by a large number of teams. Our specific team is the platform team, and our job is to basically build the logic between the features and the system. This leaves us with a lot of functional code that is no longer excellent. Some examples include EventBus, RxJava, Volley, Java itself, Realm, React Native, RenderScript. The list goes on, but if you take nothing else away, make sure you remember that libraries beginning with R will lead to tech debt and job security. So our tooling. So again, what makes this 14-year-old app work to serve 500 million people? Our team pretty much exclusively uses Android Studio. Our build is Grail Enterprise, Groovy, Python scripts, and BuildKite. And then architecture is multi-module, monolithic, and a mostly single application activity. We also had a colleague give a great talk last year about our modern architecture and how we're actively trying to undo all of our bad decisions. If you're interested, it was done and presented by Christina Lee, and it's available online. I think she gave it this at droidcon NYC and here. So if you want to, it's a great presentation. It goes a little more deeper into a lot of the other, I guess, mistakes that we made in hindsight, looking back on things. So the numbers that define what we do. Last year, our code base had over 12,819 commits. Our Android app itself is made up of over 90 full-time engineers. And last year we had 43 distinct releases, 119 if you count all the dot releases, and we release on a weekly basis, rolled out over 5 days, progressively increasing the amount so we can fix bugs and ensure stability. And a little bit of historical context now. So before we get into more details, just trying to discuss the interest of who our team at Pinterest is. I've been there 7 years, or 7.5 now. And our team name, basically since my inception, is Android X, which stands for Android Excellence. We had this almost a year and change before the libraries we know as Jetpack were all released. And this means we had to hand roll our own solutions for a lot of things that were then given to us, like architectural design patterns, data, and then lifecycle navigation, which is the focus of this talk. So basically, I kind of stated this as our statement for the talk, that something done right that's now wrong is worth redoing. I remember pretty well how 7 years at Google I/O, our entire team was there, and they announced Jetpack with all of these features that we'd literally spent about 1.5 years building. I was super proud of our MVP system, how we basically managed all these things, and then they rolled out and pulled the curtain back on all these things, like the Jetpack navigation. So what did our custom navigation framework initially look like? The core foundation of everything was this screen manager. Its primary role was to create the controllers and their respective views based on the screen definition, and then the screen manager facilitated such tasks as adding and removing screens, handling back events, animations, and more. But unlike the fragment manager and the fragments, the screen manager did not manage save instance state. So this meant we had to save this instance state basically by default within these custom views. Some other key aspects we had to manage ourselves were the tabs and the custom bottom nav bar. latest animations with the ability to reverse them, the backstack, and nested listed backstacks with relationship to the main backstack. And then we also had basic functionality, adding, removing screens, peeking at the current visibility screens, cool down, warm processes, popping different tabs, handling insertions, querying screens, basically rewriting all those things we got for free, trying to make it better. I know we all came from the keynote where we kind of went through the history. So this is basically stuff we really had issues with in Android. I don't know if you were doing it 8, 9 years ago, but these were kind of really bad pain points then. And so next, let's talk about our navigation manager. The navigation manager was crucial for managing the application navigation. It was designed to receive these navigation events and then handle them effectively. These were all activity scoped so that each activity got a single instance of this manager, which tried to enable this seamless integration with the Android backstack. And the scoping ensured that the navigation manager was tightly bound to the activity lifecycle, trying to simplify that navigation and that state management. So what did it really do? You might recognize a lot of these things from stock Android. And as a joke, I left up our principal engineer on Android and her commits, just further proving that great engineers sometimes have to work on systems that you look back on and have total pain points on. And it really just basically paralleled kind of like a lot of the stock Android lifecycle. And so some of those challenges we encountered, I tried to capture a screen of what Android used to look like in case you forgot how bad it used to be with regard to kind of all the different navigation pieces we had, fab buttons, slide from the sidebar navigation, and then the bottom nav. And so we really needed these custom logging needs and requirements that weren't addressed by these standard solutions. There weren't hooks, there weren't really ways to track a lot of these things in navigations pre-Jetpack. We had a lot of these ways we needed to basically programmatically drop into specific screens using Espresso and different flows for testing. We had really difficult problems with the support library, initially at least even, with attempting to track bugs for the support fragment manager. Early on, there were all sorts of bugs. We didn't have a reliable way to quantify what was going on. We needed customizable behavior for different warm and cold start scenarios. This was something we really needed to verify and hand roll. We needed better integration with React Native. It needed better interop overall. And there was a lot of issues, at least early on. I don't know, again, if anyone recalls, with the bottom navigation bar being problematic. Users had frequent issues distinguishing between home tabs and backclicks. And then, of course, get child fragment manager, as long as pending state transactions, state loss, other of those things we wanted to solve for and kind of resolve ourselves. As a quick anecdote, you might recall that Square published a rather scathing blog a while ago, years and years ago, advocating against fragments altogether. They had their brick and mortar flow. It's pretty convincing. It highlighted a lot of this mess that like the backstack could become when dealing with navigation. If you really want to get into history, I really recommend checking that out. So, the system worked and compounded and worked and evolved, but then two things really happened that were kind of forcing functions to make us migrate and have to move off this. The first, of course, was Compose, and the second really that was one of the root business causes were these gray-listed APIs, which we had been accessing a bunch in our custom fragment implementation and lifecycle controllers. Again, also, these screen manager and navigation pieces were completely unique to Pinterest, and they don't truly resemble any Google official or popular open source libraries. So new Android developers at Pinterest were trapped in these frequent problems and had to spend tons of time to understand everything, and it really kind of elevated the problem that basically what onboarding could be. Furthermore, again, that code was gray-listed, which we really were worried about because we felt like we had this kind of ticking clock over our head that we could basically lose listing at any point in time with a broken app because of this. So our goal became to provide a solution capable of migrating that bespoke navigation system entirely to the Jetpack navigation framework. So 400 fragments. What did we do with these 445, I believe, exact fragments in our app? What do we try and do with them? So we went in with this super high hope that we could basically go in behind the scenes and rip out everything and basically have us move to this Jetpack navigation library. One of the biggest pain points was that in the app, we didn't know which screens navigated to which, and we had serious envy of apps that did. The beautiful kind of distinct navigation graph in the editor was great. We didn't have anything like that. Because of the current state of the application, we went through this very long debate over what phase development we wanted to take. Basically, in which case we would basically try and develop fragment navigation as this little island so we can enable piecemeal navigation and piecemeal migration of these fragments to basically Jetpack navigation, or some sort of odd proposal in which each fragment was designed to function with the standard Android fragment manager and could survive in both the bespoke system and vanilla Android, which would then be followed by like a wholesale migration of all fragments to vanilla Android, which eventually we settled on Jetpack navigation because it really allowed us to stay with some like final result we wanted to end up with. It would work well with composed navigation eventually. It gave us this clean and obvious cut to our analytics system, which is a whole nother mess. It allowed us to use HILT and DI best practices. We knew how to write integration tests, and it had a clear integration with state-based architecture, which is our kind of MVI framework that we're moving on to as a modern architecture practice. And also the estimated time was a little less due to all the tech debt. So our first attempted task was to basically launch a fragment via the Jetpack navigation, which resulted in a failure because we were trying to do too much at once. Just a pure navigation, complete failure, utter mess, picking up the pieces. We moved to our second attempt, which was to move the field injection into the base fragment. So we had written this manual injection of this thing called our base fragment dependencies. Each stock fragment manager, would then go in and construct these basically pieces of information necessary for each fragment to interpret on initialization and then start up again. But basically, we needed to eliminate this complex logic. The solution required us to move the convoluted logic in these base fragment dependencies, which each fragment was receiving upon initialization, and thus basically that would allow us to pull these fields out and simplify so that we could basically slow burn each field into the parent classes that needed it, and actually whoever actually needed these fields could consume them. So this led to our third attempted task, which was forking the base fragment. So all of our fragments extend from a root fragment, quite a common pattern in old Android, and we wanted to change that so when we were using field injection, it wouldn't break the entire application, have to start at the root. And so what this got us the ability to do was to launch a demo fragment into Jetpack navigation. Great success. So we have this dev menu like a lot of apps do. We wanted to try that. We built this playground, and we found out that it did become possible to launch arbitrary fragments into the app as long as they were migrated to be launchable without parameters. Thought it was great success, trying to make simplified things to make them easy, digestible, and consumable for other people in our app org to look at and see that things worked. So the root fragment itself also was still in Java. It was an entire mess. Over 1,000 lines long, some giant God class, and we needed to convert that to Kotlin. That was a whole issue in and of itself, but once we got through with it, it allowed us to successfully integrate that into the app and the developer menu, play around with it, and prove that the migration was theoretically possible. But this is where things kind of went really poorly. We needed to now fork this fragment to the Jetpack nav host fragment style. And this made sure that now we had a single app, we had a single piece on the bespoke architecture and the nav host fragment. So we needed to jump in and out of our Jetpacked fragments along with our custom screen manager while maintaining a backstack. So that meant we now had 3 backstacks almost to manage. So we had one coming in, one coming out, and then one to basically maintain the God backstack. So we had all of these things watching each other. It also turns out that the XML graph from navigation is built for one entry point as a root of a tree, so we had to get really hacky with how to get in and out of that. We got sad, we got filed with a bunch of bugs, and we were told that we were holding on to everything and these references completely wrong. the forked fragment was able to be compiled, but there was no good way to basically maintain this so that everyone could kind of go through it. There wasn't a simple migration flow. And this led to our 6th attempted task, which was removing the need for these fragments dependencies. We give up. We wanted to make sure that we were able to launch fragments into the fragment manager transaction like we did with the first attempted roll. And basically, we had now scrubbed these constructor parameters because we have had this basically custom fragment transactions allowing us to do these base fragment dependencies. We still needed all these fields. But we knew we couldn't get to where we wanted to go, so we rolled it back a little. Prototype success. So this quote is attributed, I think, to Coco Chanel. But the real piece of this that I liked was that the slide layout's broken. There's no way to replace that image, which I thought was like a perfect segue to this kind of how we failed and made it a success. So again, we started designing this system in the forked architecture because it felt like a really simple transition to Jetpack navigation while still retaining the old logic. However, after we started working on it, it became really evident that we needed to develop support and fork all of our parent classes, forking 445 parent class, forking 445 fragments, parent classes, and everything because of our architectural choice of inheritance as a strategy is something I would not recommend. It's 1 out of 10, wouldn't ever want to do it again. But we realized quickly that when speaking with people trying to get buy-in, that this would also result in huge instability just due to the large number of classes you would have to maintain. We're essentially duplicating everything. Everyone trying to migrate a feature would have to essentially support these 2 things. It would block production releases, just a huge mess, and it wasn't going to work. So what happened in those 40 days to make it a success? Quick recap. Our plan was super ambitious. We wanted to migrate our bespoke navigation system entirely to the Jetpack navigation framework. And while this objective was commendable, it really proved impractical. The Jetpack navigation system required all this extra overhead, all the extra safe R constructors, the nav graph, XML construction for each fragment in the migration, and the deep linking directives, which is a whole system that we also built bespoke that now needed to be migrated to support this. So given these challenges, we had to redefine the project scope, which is hopefully what we want to give you to help anytime you run into a wall, so that anytime we run into this, you might see that basically how to help lay these groundwork foundations for future success and future integration. What we did was we aimed to deliver our application now in this sort of general availability without enforcing that centralized migration. And we avoided imposing a mandate for immediate transition because we know that when you basically are a platform team and you impose a mandate for something, you get nothing but pushback, even from the best of engineers, just because you're adding engineer work time. You're adding people a mandate, you're coming with the stick instead of the carrot approach. And we believe that this approach allowed us to move forward effectively while preparing for future enhancements. So, what became the success metric? We now knew that there was no way to deliver our original objective in a way that wouldn't result in this multi-year long effort to change everything. So we were trying to evolve the story of this task by evaluating what we really needed in phases into these manageable tasks. So what we came up with were splitting the project into modern lifecycle readiness, lifecycle implementation, and navigation implementation. And what our first and successful project became now was this modern lifecycle readiness, and we came up with this process called fragment certification. So to enable and to make sure that a fragment was certified, what we needed to do was to now make sure that all these fragments had these zero argument constructors. We needed to ensure that all parameter injected elements were not accessible until after super on create. Currently, there were instances where the parameter injected elements were accessed before the super on create in the init block, crashing the app, leading to unexpected behavior. And the biggest challenge was really fixing this to ensure proper initialization of the fragment at all times, and then testing and verifying the features worked as expected. so that configuration changes wouldn't cause any loss of data or improper behavior. And whenever possible, testing that that fragment could be launched in an empty default argument and behaves properly. So once we found this right road and we knew what we were doing, this helped us determine what a good result looked for, even when things didn't go as planned. So we wanted to try and give you hopefully helpful steps for controlling this redefinition when you're presenting to someone, key stakeholders and everyone else when things go sideways. Our first recommendation is really to identify the impact you're providing. No organization is going to implement a change unless they see the value that it brings or the risk it mitigates. It's essentially the only thing you need to do to get this to have any sort of force is to identify these risks and changes addressed and develop solutions that these stakeholders will define as success. And personally, one of the most effective strategies I've used to control this kind of narrative is to really discover and understand what your boss or the key stakeholders need to deliver and define as success, and then deliver that. That should be your primary focus, as it'll generate the most impact over everything. Ensure backwards compatibility. The hardest part of any migration is that transitional phase where things need to be interop between the first state and the second state you need to get to. Some users are going to be in the old versions of the API, while some versions are going to be on the new one. To manage this, we really recommend that you basically want to account for this transitional support in your plan and have backup plans so you're prepared for when scenarios arise where things don't go well. This includes having things like feature flags, rollback plans, and basically people who are on point and experts in each scenario who can help define how to fix these things when things go wrong. Third recommendation would be make sure you define the current migrating and end states of the project. It's crucial that all internal teams and users understand what they're using, what's changing, what we plan to achieve by the end of this migration, and we have well-defined states, actions, and timelines that are key to smoothing transitions through various migration phases. Excuse me. We want to make sure also that we manage legacy code to new code. Mapping of legacy code to new code. Our recommendation for this are make sure we have a mapping of local groupings. So each of the phases should be grouped into these clearly defined states. This helps identify in what phases entail and tracking the progress when things go awry, and change mapping. Makes sense to do this any way possible, but what you want to do is map the old functionality to the new functionality. This creates a change map similar to like a diff view in code, allowing you to understand what's changing and then expose that to everyone else. And then finally, our last suggestion was set up the tools to monitor the progress. Plan and set up monitoring tools, establish reports and monitoring tools to track your migration's progress. This also helps in managing the migration effort effectively, but also sometimes more importantly, ensure that your project is accurately tracked and reported. Success is going to manage who knows the success, so it's going to be judged by the consumers, but also the people viewing the project. So, again, we're not 10x engineers, so how did we manage to migrate an entire code base of over 400 fragments in just 40 days and then give a talk in 40 minutes on it? Our key takeaway was basically paralyzing the work after we went through all of these phases. So we spent significant time with the code base beforehand. This allowed us to really identify these distinct tracks, enabling multiple engineers to work towards the same goal simultaneously. And then before diving into our goal, we built support for it. Think of linters, code generation tools, templates, testing methodologies, playground, and sandboxes. These tools minimize the overhead and then streamlined basically the success for the process. Establish a clear chain of command and ensure there's always someone available to answer questions. Also extremely important, identify who will fix things when they break, replicate and develop a success pattern. Develop a pattern or recipe for success and replicate it. Make sure you have PRs that represent everything. The pattern itself should cover about 80% of the use cases. Focus on keeping it close to something like the Pareto principle, where 80% is going to cover 80% of the work people are going to do. 20% are going to be edge cases, no matter how well you develop a system. And if the task is too complex to be standardized, try to break it down further. To emphasize, for me at least, the key takeaway was really build before you build. Know your code and really get to know everything that's going on. This allows you to lay the foundation for the right tools and plans Establish clear lines of communication and replicate proven patterns because you know what you need to identify and who to talk to. So sometimes you do the hard work up front and the payoff's a really great success. And so this is how we got unblocked and delivered a massive scope change in a little over a month. What did we cover? The key points I hope you could take away and enjoy from this talk was covering our bespoke navigation, how bad it was, the crucial roles that the screen manager and the navigation manager played in constructing views, and the legacy code we needed to change, challenges with the custom requirements, address custom logging, testing needs, and the support library issues, as well as the navigation and UX problems. Our migration strategy, the practical alternatives we opted for instead of direct migration to Jetpack navigation, including laying the groundwork and the phased integration, stakeholder alignment, emphasizing the importance of understanding and delivering when stakeholders need something that you can't deliver, how to manage that transitional phase effectively, and hopefully setting up something that allows you to build your project into a success. Paralyzing work, how we managed to deliver and migrate over these 400 fragments in 40 days by basically paralyzing the task, giving a team an ability to run with it, and having them spin that up so that they could operate independently without minimal support and overhead, defining clear communication channels, and then making sure that we enabled things, again, to go smoothly once we hit that fail-safe. So anyway, that brings us to the end. Hopefully you took away a few bits of information that'll help you on your next project when you all run into a wall. And thank you. My name's Adam Greenberg again, engineer at Pinterest. I'm not on many of the socials, but you can find me at my GitHub. You can find me on Mastodon and a couple other places, Adam MT Greenberg at, and then Kurt Nelson's contact. We have the QR code up if you want to find our presentation online or review any of the speaker notes. And thank you again for your time and coming to our talk.